Good morning, everyone. My name is Ayush Kumar Kotadia, a master student in electrical engineering. Today, I'm excited to present to you my project on real-time face mask detection using deep learning under guidance of Professor Cheng Chu. So let's take a quick look at like what we'll be covering today. So our agenda includes the abstract introduction and the basic comparison of existing and a proposed system. Apart from that, there are some literature survey and overview of different models like sequential VGG16 and MobileNet V2. Followed by also I'll be covering that loss and accuracy graph of these models, and we'll then dive into the resulting outputs and wrap up with the references. So first of all, in abstract, in my project, I develop a model to detect if like people are wearing face masks properly in real-time video streams. So this can help enforce like mask compliance in crowded public settings to mitigate that virus transmission. So for that, I come with like utilize a deep convolution network like MobileNet V2 and VGG16 that is a pre-trained on image dataset and optimize them for a facial mask classification. So my goal is to create an efficient and accurate real-time mask detection system that is deployable to embedded devices like Raspberry Pi. Yeah. So after that introduction, the COVID-19 pandemic is like widespread around the world, like there are due to mask wearing globally. So my project aims to apply deep learning and computer vision techniques to automate a mask monitoring system through live video feeds. So reason of this project is like this reduce a human effort in crowded environment like offices, transit stations, stores, where manual enforcement is like infeasible. So my classification models can raise timely alerts on improper wearing to help curb infection spread. Now, if I talk about existing systems, so existing mask detection systems have a limitation in detection accuracy. Apart from that, like model efficiency is suitable for real-time usage. So here, what I'll be do that is like different. What like my project focusing on optimizing deep CNN models to balance accuracy and speed while like also customizing for robust facial mask classification from live streams. Now, like my project proposed a two-stage of mask detection architecture. Firstly is like a face detector localize human faces in images. Apart from that, in videos, then a second CNN classifies each face is either masked or it's non-masked. So lightweighted CNN architecture allows like in a way that efficient processing for a real-time video streams. So I optimize the top performing models like MobileNet V2 using real world facial data set. So that I will be covering in my project. Yeah. So there are like some of the deep learning models. So I surveyed like different state of the art CNN architecture. Like you can see in here in slide, there are sequential mobile nets and VGG16 for a facial classification task. This study shows that models like mobile net V2 can achieve like up to 99% of accuracy for mask detection. So I use these prior works to like guide my model for training and hyperparameter optimization. So my goal is like extending high accuracy for real-time usage. In next three slide, I will be covering all three models of that like architecture and what are the results of that. So here you can see that sequential CNN architecture. So I develop a 7-layer sequential CNN model that is customized for facial mask classification. It has two convolution layers that using 3 by 3 filters to extract spatial features, followed by like max pooling to condense the representation. Apart from that, I also include that flatten layer to project the 2D feature maps into a 1D vector. Then the next layer is a dense layer with a ReLU function that activate a prediction of a probability over a mask or no mask classes. So how we can identify there is a mask or not. I trained this architecture on mass facial dataset for like 20 epochs using binary cross entropy loss. So we can achieve like almost 98.99% of accuracy on unseen test faces. Here you can see also the diagram for that, indicating like a robust learning of facial attributes that correlating with our mask wearing. So most probably like this demonstrate that compact CNN model can differentiate like mask face efficiently. So here in next slide, you can see that for VGG16 architecture is like widely used for like a 16 layer CNN architecture that is for visual classification that transfer learning of initialized weight from facial recognized mode and customize the last classification layer for mask detection. So that is we can say that image augmentation via like rotations, zooms, shift boosted and dataset diversity. So after training all the like facial data set for 20 epochs, like this model achieve like 94.27% of accuracy. Here also you can see that VG16 architecture in that feature hierarchies like learned by intermediate layers allow like we can detaching common facial attributes that is predictive of like mask patterns. And apart from that, this shows that values in transfer learning from facial recognition for robust marks classification. And now it's architecture for mobile net v2. So I utilize that mobile net v2 which use like a depth-wise separable convolution to build a lightweight models that is suitable for like in mobile development. If we want to like deploy on mobile like mobile set, then we are using this architecture by turning like mask facial data. And in this I achieve almost like 99.25% of training accuracy after 20 epochs, so with like stable loss curve convergence. This outperforms like VG16, indicating like separable convolution better extract feature that is correlated with mask wearing like nose and mouth patterns like while reducing computational requirement. So this model efficiently combined with high accuracy that is like demonstrate on potential for extending mask detection for real-time embedded usage. Now in this graph you can see that the sequential like uh, for sequential CNN model, what are the accuracy convergence over the 20 epochs, right? So it you can see here that it reaches almost like 98.99% of accuracy by 12th epoch. So with like little fluctuation thereafter, that indicates that the robust learning of facial features like correlated with mask wearing. And also you can see for that training loss that is declined smoothly from zero point 0.6 almost zero point 0.6 initially to 0.34 that is like oscillate occur due to batch adjustment, but the overall downtrend signals reliable on like model convergence. So low loss aligns with the high classification accuracy. In next slide is like model accuracy for VGG16 model. So here you can see like it's constantly from 50% to be going to peak like 94.27%. So it's like more capacity in this 16 layer architecture. It's like account for higher initial uncertainty. So you can see like gradual uptrend shows that progressive features for this learning mask detection. However, the loss fluctuation early on signifies some variability in learning mass. So, but here, like you can see that, but steady decline subsequently highlights the adaptation to variety in training data and final convergence. Next is the graph for mobile net v2 accuracy. So in that, it's like elevates steeply from 60% to 99.22%. And we can get like after 9 epochs, right? So stabilizing thereafter, that is like rapid accuracy improvement indicates that efficient feature extraction to like depth-wise separable convolution. So it also like aligns with smoothly decreasing loss. This signals like robust model for convergence capitalizing with like lightweight yet like accurate architectural design. Here are the result for the output samples. So there are like examples you can see in images using like VG16 and my custom CNN model. You can see that with mask and without mask, there are like various facial images, along with like you can see here also in like localization boundary boxes. So this qualitativity validates the model's learning. So in these all pictures, you can see that without mask and with mask, how it identify the result. In next slide, you can see the result, like experimental result. So I evaluated all models on consistent taste data set that is like containing properly masked faces lacking mask, and those with mask are not covering noses. So the MobileNet V2 and sequential models achieve almost over like 99% and 97% accuracy respectively. So for properly masked faces. So despite like diversity in mask type, there are also reliable detect improper wearing, exposing like noses. This is promoting for enforcing to like stop masking compliance in public setting. So they have a fewest error. Some of the case we can like detaching complete lack of mask across models. So that highlight learning of robust uncovered facial features. But here it's like lower accuracy distinguish nose exposure shows that like a potential area of improvement via augmented training data emphasize, right? So overall result validate like feasibility of almost like greater than 97%, that is real-time facial mask detection using streamlined CNNs. So yeah, what are the future scope and work we have to do? So while current results are promising and we get like almost 97 or 99% of accuracy, so I plan to like improve like multi-phase detection consistency and achieve like more fine-grained classification accounting for mask type and proper nose coverage. So integrate that user feedback can enhance model for the robustness, and I will also like optimize the model efficiently to embedded edge devices also. These all are the references that I leverage is this paper on topic of deep learning for computer vision, and for face mask classification model using CNNs like mobile nets, and some of the COVID-19 transmission control. So I use this reference to guide my project's model training and methodology. Yeah. So thank you.